At the time of making this video, the world is in deep shit. The Russian invasion of Ukraine, which is not ending anytime soon, the crazy high oil prices, the hiking of interest rates one after another, companies screaming end of the world and firing their own employees. And all these with the growth companies' stock prices crashing and burning to the tune of Amber's fake tears. How do I even restart my YouTube journey? I've been teaching biology since 2004. On this channel, I hope to simplify and explain the science behind the companies that's driving the genomics revolution, one video at a time. I've been making videos, it's just that they are not on YouTube, but are for my own students instead. Now, I'm back trying to make sense of this turbulent world through the lens of biology. Because of my irregular upload schedule on YouTube, if you are still keen on my videos, please subscribe to catch wind of the next release. Outside of work, I've been spending as much time as possible with my loved ones because life on Earth is just too short. But we have been dealt with a shitty situation right now with the macroeconomics. Still, I'm thankful for what I have, including you who have returned back to this channel to hear and see what I have to say in this new video. Patience is very rare in today's stock market, with investors behaving more like traders expecting returns yesterday. As much as I love Beam Therapeutics, my favorite gene editing company, I've set pretty low expectations of them and I'm willing to wait it out for the rest of the decade. Science is not like software companies that can just launch and grab market share as long as you throw money at it. Even Tesla needed 10 years before their stratospheric takeoff. And even then, they were almost bust many a times. And on that note, many are expecting Beam Therapeutics to speed through clinical trials and produce a blockbuster therapy. It does not work like that, my friend. Ayo! Prior to testing humans in clinical trials, a company that produces a novel therapy have to test it extensively on animals. This part does not sound as important, but it has tremendous implications for the clinical trials of humans that come after. Let me highlight one potential problem. Telomeres are found at the ends of each human chromosome, and as you can see in this diagram I've given you, they are specifically stained for and appear yellowish. These structures are a buffer against the loss of genetic sequences as a result of something known as end replication problem. So you might be asking, what are end replication problems? This is a process that describes the gradual shortening of the DNA molecule after each replicative cycle, which can be a potential problem because you are going to lose genetic elements on the DNA. As a solution, telomeres act like disposable genetic elements that can be sacrificed as end replication occurs from one cycle to the next. In addition, telomeres are recognized and bound by a group of proteins that resembles that of the plastic wrapping the ends of shoelaces. They have an important role in protecting the ends of linear chromosomes. However, as end replication continues, the DNA molecule will continue to shorten, losing the telomere sequences. When there's not enough telomeric sequences, these group of proteins are now set free. And the end result when they are free is the activation of a sequence of events, one of which is very important, is cell death. The idea behind this is that a cell should only have a limited lifespan. The more cell division it undergoes, the more mutations it can accumulate, leading to some of these cells becoming diseased. On one hand, the cell is trying to prevent the accumulation of mutations. On the other, we age because of the cell deaths. So what have telomeres got to do with animal testing? Let me put two and two together. The animal testing process typically starts off with mice, and some mice strains are preferred over the others. And coincidentally, these mice tend to have longer than usual telomere lengths. The longer the length, the longer it can survive. If the novel drug harms cells, the effect may be masked. allowing the drugs to show a positive result with little to no side effects when observed in these mice. Ayo! When these drugs go on to be tested in humans, that's where potential problems can arise. Isn't it curious that every so often we hear of serious side effects in human clinical trials when the same novel therapy seems to have sailed through animal testing? One of them is the horrific story of TGN-1412, which I will detail in the next video. It was quite a nightmare for the company that produced it, which subsequently went belly up.